Hi guys, and welcome to lecture 5 of Python programming with me, Mace. So in this lecture we're going to be going over the next essential part of chapter 2 in binary. So because we're going to be learning bitwise and logical operators, we need to know how to do operations in binary, such as addition. Oh, whoops, that's not a very nice addition. Addition, subtraction, multiplication, and division. Okay, so how do we do those? We'll get to that in just a minute, but first of all, we're going to be learning how to sign negative in binary. So there are two ways of doing it. One, 2's complement, which sounds really weird. 1, 2's complement. Anyway, which is literally getting your binary number. So we'll do 10010, which is 1. Okay, we'll just put our places here. 1, 2, 4, 8, 16. So that's 9. And we want to represent it as minus 9. So how do we do minus 9? We could just write down minus 9, but because the computer doesn't recognize that, whoops, I was just fixing up my arrow. Because the computer doesn't actually recognize minus 9, we've got to actually show that in binary. So in 2's complement, let's change this number because it's not the greatest example. 2 zeros in front of it, so that place value changes. So sorry about doing that. 1, 2, 4, 8, 16, 32. Okay, so now you've got 32 plus 4, which is 36. There we go. So you got 36, and you want to make it minus 36. Ooh. Okay, so how do we do that? First thing we're going to do, in 2's complement, this is our first method. We're going to use the 1-bit method later. So first of all, we got to look at the number. So our number right here is 101001000. So we look at the number 00100010. And now we've got to actually look at the first one. So we're going to be calculating from the right. So you just look at the first right bit. Is it a 1? No. Second rightmost bit? Not a 1. Third rightmost bit? It's a 1. So everything after that, we got to block off. Let's get a different color. We got to block that off. And what we now do to the number is we keep all of these the same. They're not infected. But the rest of them, we make them opposite. We do use complement, which is making it different. And there's actually an operator, a bitwise operator for this, which looks a bit like this. I'm looking at my keyboard right now. Yes, it's the tilde symbol right below your escape key. And that's the complement operator in bitwise, which literally makes it opposite. Except for in 2's complement, making it negative, we actually have to not change the 1 and the 2 zeros that are trailing after it. So that is minus 36. But it can also be known as the number we see right here. If we look at our place values, that's 64. 64 plus 16 plus 8 plus 4, which I can't be bothered to calculate. But that is a totally different number from minus 36. So the computer can't actually understand that that's minus 36. However, you can understand it. And when you do operations on the computer and when you enter stuff, then the computer will assess minus 36 as this. And yeah. Okay, so now that we've gone over that, let's go on to the second method of doing it, which is 1-bit. Plus 1-bit. So even though 2's complement is used more, plus 1-bit, definitely more simple. I mean, in my words, personally. So you've got 36 again, 01001000, and instead of actually worrying about all these unnecessary things, we don't actually have to worry about the number itself. In fact, the only thing we're going to make orange today is this empty space right here. Empty. Yeah. Oh, whoops. That empty space right there is all we're going to worry about. So imagine we want to do something like positive. We could write the positive sign or the negative sign. However, the computer can't understand anything apart from 01001000. So we've got to turn those negative signs and positive signs into binary. And that's how we're in 0 equals plus and 1 equals minus. Literally. So if we put a 0 at the front, you've got positive 0, 1, 0, 0, 1, 0, 0, 36. And if we put a 1 at the start, well, you've got a negative, which is what we're looking for. So now this, at the same time, is also the same as this. Weird, right? Yeah, I know. It's the same binary in two different forms using two different methods. So yeah, definitely the 1-bit method is better looking and easier to use, but the 2's complement is more used and it's definitely more accurate. So now that we've gone over negative, let's go over some operations. Everybody loves them, right? Plus, minus, multiply, divide. Whoa, big, right? They're not really big, but anyway, whatever. Oh, whoops. Yeah, anyway. Okay, so how we do these operations, let's start with plus, because everybody learns plus first, and yeah, everybody learns plus first. So, let's do 0, 1, 0, 0, 1, 1, 1, 6, 7, 8. There we go, 8-bit, plus 1, 1, 1, 1, 1, 1, 1, 1. I've realized that doing that is just really handy. And by the way, that is the largest 8-bit number possible because it's all ones and it's 8-bit. So we look here. Oh, whoops. Okay, there we go. Okay, so the answer to that is definitely going to be 1 plus 1, which we cannot do. Every other operation we can do. 0 plus 1 is 1, so we could do that. But we can't do 1 plus 1 because we can easily put a 2 there, and wow, that works. I mean, we can. The computer can definitely understand 2. Yeah. Anyway, so we do 1 plus 1, but instead of doing that, we put 0 here. We put 0 there, and we make that a 1, which is another 1 plus 1, right? Okay, so now we've got the same thing we had before. 1 plus 1, 0. So we have another 1 plus 1. So we do 1 plus 1, which is another 0, sadly. And we put another 1 there. Now we have 3 1s. So we can't just put 3 there. Actually, we all know that. But we can't put 0 here and put 1 there. Sure, that works. It's like we're ignoring the extra. Let's get rid of that. 1. So what we do there is 1 plus 1 plus 1. We put a 1 there. We're literally adding another 1 and putting a 1 there. Now we have 1 plus 1, which is 0. And we put the 1 there. Oh my gosh, this is going on forever. 1 plus 1, which is 0. Put a 1. We put a 1 again. And we put our 1 here. We put a 1, 1, 1. Ta-da! We have our answer to this question, which is 1, 1, 1, 0, 0, 1, 0, 0. But you may have realized here, actually that is not the complete answer. In fact, if you look at it right now, you can realize that, hey, this is less than this. You're adding, but it's less. What's going on? So we've actually got to expand this. We've got to expand this from 8-bit. We've got to make it a larger form. So we go 1, 0, 1, 0, 0, 1, 1, 1. And if anybody picked up, I left that 3 ones. We need to do it. We need to keep doing it. So let's make that. Oh, whoops. This. 4 more zeros. Okay, we'll add 4 more zeros, and that makes it super long looking, and just don't mind it. So we'll skip putting everything over. We'll just do 0, 0, 1, 0, 0, 1, 1, 1, and we were finished there. 3 ones. And we've literally got to keep going. So we've got the 3 ones, and then now we know what to do. We put the 1 here, right? 1 plus 0 is 1. And we got the 0, 0, 0. And ta-da, we've got it. So actually I didn't need that. But now we've got in 9-bit form, which is really like not perfect at all. We've got it. So that is actually 512. That one right there. So this number plus this number is not this number, but it's actually this number. So never leave your operation hanging. Do not leave it like that, because you're going to get it wrong. So just keep on going. So I've actually had to expand into 9 bits, which that's the result of choosing a random number. But anyway, so let's choose a more simple operation to do, maybe not with a larger number. So let's do 111,00101 plus 0110111. So we go 1 plus 1, which we all know we can't do, so we put a 0 there, we put a 1 there, we do 1 plus 1, 0. We do a 1 plus 1, and that's 0. 1 plus 1, which we can't do, so we put the 0 there, we add another 1, and 1 plus 1, which is a 0. So don't mind, as long as you've got 2 1s, just don't mind these zeros, really. So then we got the 1 plus 1 is 0, we add another 1 there, 1 plus 1 is 0, we add another 1 here, and well, we got the 0, 0. So we put a 1 there, and we don't have to do anything. 1 plus 1, that's a 0, the 1 there, that's a 0 there, and we add our 1 there, so now we have 1, 1, 1, and as I said before, if you have 3 1s, remember what to do. You get 1 there, and carry the 1 there, and you have 2 1s, and oh no, we've got to keep it going again. Ooh. Okay, we've got to add more bits now, because 1 plus 1 is 0, and you've got to carry that on 0, and you put your 1 here, and you put your 1 there. So that just about works that one out as well. Okay, so now that we've done that, we've done our addition, and that's enough examples to understand. Let's go on to the other 3 operations, and you're just like, oh no, that was only addition. No, but we've got the other 3 operations. So let's do 0, 1, 0, 1, 0, 1, 2, 3, 4, 5, 6. In fact, this time I'm only going to make it 6 bits, so we don't extend ourselves into 9 bits. Actually, no, this is subtraction. Now, in subtraction, you're going to make sure you're subtracting a larger number from a smaller number. So let's see what this number is. So, whoops, 1, 2, 4, 8, 16, 32. So you do 1 plus 4 is 5, plus 16, 21. So you've got 21 minus, let's do 0, 0, 1, 1, 0, 0. And I know that's smaller just by looking at it. In fact, we might even add 0, 1. So that's 1 plus 4, which is 5, plus 8, which is 13. So we already know by looking at that, the answer is going to be 8. But let's do this in binary, because we're looking at a computer's perspective, and computers aren't as smart as us. Okay, 1 minus 1, 0. 0 minus 0, 0. What you may have realized, which I forgot to mention, from both of these, we're just using the conventional way of doing it, but when we get to exceptions, such as 0 minus 1, and in the last one, 1 plus 1, we've got to do something different. So same with this one. 1 minus 1, 0. 0 minus 1. However, that is an exception. So what we do is, as usual, we make this a 0. However, we got to carry 2 1s here, and you may be thinking, well, how does that work? Well, the thing is, you've got a number here, 16, right? And you've taken a whole 16 away from this 21. You've turned this 21 into 5. You've taken 16 away from the 21. So what do? You put 2 8s in its place. So you're not changing the value. So now you've got 2 minus 1, which is 1. 0 minus 0, which is 0. 0 minus 0, which is 0. And that is 8, which is, if you look down on little place value table, yeah, you've got your 8 right there. So that is subtraction. So for addition, we found out that what could you call it, exception is 1 plus 1, and you just deal with that by making it a 0 and putting a 1 in the next one. With a minus, we figured out that 0 minus 1 doesn't work. So all we do is make that 0 into 2, and we make that 1, right? So those are the 2 exceptions, and minding these exceptions, you can literally do these operations the same as you would do any operation. So that brings us to our next operation, which is multiplication. So multiplication, how do we do multiplication? Say you have the number 0, 1, 0, 0, 1, 0, 0, 1. 1, 2, 3, 4. Actually, no. We don't want to do 8-bit because remember, it's really it gives us a lot of bits. So we'll just do 4. 4 times. Let's do something simple. 4 times 6. So 6, as we already know, is 4 plus 2. So we go 0, 1, 1, 0. Okay. So let's go 0 times 0. So this is literally the same. As I said before, all you got to do is handle the exceptions. In fact, we'll actually talk about exceptions in multiplication later. But it's literally the same as long as you mind them. So 0 times 0 is 0. 0 times 0 is 0. 0 times 1 is 0. 0 times 0 is 0. And now we move on to our next place. So we just add that 0 there. 1 times 0 is 0. 1 times 0 is 0. 1 times 1 is 1. And 1 times 0 is 0. And now we can add our... Oh, that just looks weird. Now we need to put 2 zeros there because we're moving up another place. And because we're multiplying by 1 again, we can literally just do what we did before. 0, 0, 1, 0. And now you do zeros, which is always going to be all zeros. So you just do 1, 2, 3, 4. Okay. And I really didn't need to put that last row in or the first one, but we're just showing you that it is literally the same as what you would conventionally do. So 0, 0, 0. So you got your zeros again, your zeros again, your 1, your 1, your 0, and your 0. And now you've got 24, I hope. So we've got 2, oh, whoops, I keep doing that. 1, 2, 4, 8, 16. 16 plus 8, 24. So you've got 24 there. So now you may be wondering, well, when we get to this addition, what if you have all ones here? What do? Well, you do literally what you would do with normal addition. So let's go 0, 1, 1, 0 times. So we'll do 6 times 1, 1, 1, 1. Okay. So 0 times 1 is 1. 0 times 1 is 0. 1, 1, 0, and you can realize that if we do times 1, it's just going to stay the same. So we can do our adding place 0, 1, 1, 0. We're moving up another place 0, 0, 0, 1, 1, 0. Moving up another place 0, 1, 1, 0. And I think 1, 2, 3, 4. Yep, that's 4 places. Okay. 0, 1. You got 1 plus 1. Oh, let's put 2 there. No, remember what to do. So we don't put 2's there. Instead, we've got to put. Let's actually move that one over. It's quite confusing. Okay, so we'll just make that 0, right? Because 1 plus 1, you can't do 2. You do 0, and you turn that into a 1, and then you make that 3 ones now. Oof. So you have 3 ones. So now you're going to turn that into a 1 and then put our next 1 there. Now you've got 3 ones again. Oh my gosh, lots of 3 ones. Put 1 there and then you put 1 there. Oh, yeah, that's just confusing with the numbers. You put the 1 there, you put your 1 there, you've got your 0. You put the 1 there and 1. And you may be realizing, oh, what if I have all 1s like that? Well, the thing is, this is binary, right? So you're never going to have any numbers like that except for that. Except you're only going to have the digits 0 and 1. So you do normal addition. So now you've got, let's actually see what that number is. So we got 1, oh, we'll put that there. 1, 2, 4, 8. So that's 12, 13, 14, 15 times 6. Yes, 15 times 6, which is 90. Okay, so let's see if that's 90. So you've got 1, 2, 4, 8, 16, 32, 64. So you've got 64, 74 plus 6, 80, plus 8, which is 88, plus 2, 90. Okay. So that's your multiplication. cleared up, and there's literally no exceptions in this one, which is quite interesting. It's literally like normal multiplication. I could have said normal multiplication, but I showed you anyway. You got division now. All working. So now let's look at division, and as I said in multiplication before, actually, it's literally the same formula, and there's no exceptions. In plus and minus, addition and subtraction, better say, there are exceptions. But in multiplication and division, there are no exceptions. You go the exact same as you normally would. Notice, however, in division, it's good to do long division rather than short division. So let's do that. Now let's handle these digits, not as ones and zeros, but actually visually as numbers. So let's handle this as 10 and this is 11. Even though it sounds weird, it's better for us to understand. Even though internally, for the computer and how we're actually doing it, we're not handling it as 10s and 11s. So how many 10s go into 1? 0. How many 10s go into 11? Well, we all know 1 10 goes into 11. So we put our little 10 here. We put our negative sign here. We put minus here. And we want to take them away. And we know how to take away binary. So notice when you do this, you don't take away as normal. You've actually got to take away in binary. So 1 minus 0, 1. 1 minus 1, 0. And we bring our 0 down, so we got our 0 here. How many 10s go into 10? 1 10. And 1 10 goes in. And so now we just got to go minus. And you've got 0. Wait, we've still got a digit left. We got our 1. How many 10s go into 1? Sadly, 0. So we bring down our other 0. How many 10s go into 10? 1, right? So we do 10 minus 10 is 0, and that wraps it up, and we put our 1 there. So this actually right here was actually, let's do a huge circle around it. Actually, that circle's not neat. That's still not neat. Anyway, so that was actually 2 divided by 1, 2. Let's put our places there. 2 plus 4. 2 plus 26, which is 13, as we can tell right from looking at it. Let's see if that's 13. So 1 plus 4 is 5, plus 8 is 13. So yeah, that's binary long division, and yeah, you've never heard of the concept, but it exists, quite interestingly. So what you've just seen there is binary maths, and it's literally like some imaginary maths, some different maths, and yeah, it's really cool to learn. So that wraps it up for today, and I've gone through it a lot. And I'll be going over the bitwise operators in the next video, and how we can use bitwise operators. And that's probably the one thing we've been really working up towards in this chapter. So I'll see you guys in the next video, and I hope you enjoy.